Civil Engineering Academy, helping you in your journey to pass the PE. Alright, welcome to Civil Engineering Academy. Today we're solving a problem for construction. It states a local city must make an assessment about the feasibility of repairing a bridge. The estimated useful life of the bridge is 25 years. The MAR is 7%. The relevant cost estimates are found in the table below in thousands of dollars. What is the benefit-cost ratio of making repairs most nearly? So here's our table. Alright, the first thing we need to do is look up what the benefit-to-cost ratio is. That basically states that you need to find the present worth of all benefits. Present worth, okay, of benefits, all divided by the present worth of your costs. So we're given this table and we're giving the bridge as it is existing and how much it's going to cost to repair and the salvage value after 25 years. And if we repair it, how much the initial cost is and how much the maintenance costs are and how much salvage is after 25 years. So we need to figure this out. And if you are using the Civil Engineering Reference Manual, Chapter 86 goes over this benefit to cost ratio. And then you're dealing also with the MAR, which stands for the minimum attractive rate of return. So we're dealing with an interest here of 7%. Minimum attractive rate of return. Alright, so let's try to find what the present worth of our benefits are. And that's basically going to be from years 1 to 15. We have to figure out that we basically have $7,000 is the difference between years 1 to 15, which is 11 minus 4. Okay, and from years 15 to 25, you have $10,000. These are in thousands of dollars. So for years 1 to 15, we're basically dealing with $7,000. And we have to multiply that. And if you remember how to do this, this is your economics. So we have to find the present value given an annual value. So we're saving, this is $7,000 per year for years 1 to 15 that are a benefit to us if we repair it. So that's going to last for 15 years at 7% interest. 15 years, 7% interest. If you don't remember what I'm doing here, basically I'm using this to go look up in the interest tables, which are found in the Civil Engineering Reference Manual. Tables A-154 is what I'm going to be using for 7% interest. And that's going to give me a value that I can multiply this by. So we have some sort of, normally you draw these out on little charts like this. So we're taking 7,000 and we have an annual cost, which is represented by these arrows, 7,000 for 15 years. If I drew 15 of them out here, so that's not accurate, but we're taking this annual cost and we're bringing it to the present into one big lump sum. Okay? And if this was years 1 to 15, we're taking that annual and we're taking it to present dollars. Okay, so 7,000 times this value we're going to look up. And what does that give us? That value that I find is actually, so it's going to be 7 times, the value is 9.1079, which is going to equal 63.755. Okay, so now for years 15 to 25, we have to look at this we're saving $10,000 per year. So we got to take 10,000, 10, do the same thing, find present value given an annual benefit times another 10 years at 7% interest rate. And then we also have to multiply that by another 15 years to bring it back to basically the beginning year. So we've got to find present value given a future value times 15 years at 7% interest rate. So if we were to draw this out again with this little diagram, first thing we're doing is very similar to this, only what we're dealing with is we're starting at year 15 to 25. So 15 to 25, this is 10K for every year annualized, and we're saying find the present value. So we're going to take all of these annuals and we're going to take it to a present value. But the problem is the present value you're dealing with is at year 15. So now we're going to take year 15, which is this some value here, and we've got to bring it to, so this is a future value, and now we've got to bring it to the present, year 1. Okay? I hope that makes sense. If this doesn't make sense, then we probably need to review the CERM about engineering economics and trying to figure these out. If you have questions about it, let me know in the comments and I'll try to answer them as best I can. Okay, so what do we get here? We got 10 times, go to the table A-154, and for P over A, 10 years, 7% interest, I get a value 7.0236, and then I got to multiply it by P over F at 15 years, 7%, and if you look that up in the same table, only we're looking at the P over F column. For 15 years, I got 0.5083. And what does it give me? 35.7009. Okay, so that's the benefits. This is all benefits. Now the cost. The cost, all we need to do is take the initial cost and minus the salvage value. So if we look at the salvage value at the end of 25 years, we just got to look at the difference here. So that's $15,000. Our initial cost is $80. So what we need to do here is take, not $80, 80,000. So let's take our 80 and we have to subtract out the salvage value that we're going to get at the end of 25 years. But the $80 is our present value, and this value is after 25 years. So we got to bring it to present dollars. So let's take the $15,000 of salvage value, find present value given our future value at 7% for 25 years. And if you look that up in the same table, table A-154, for 7% interest, P over F column, 25 years, you're going to get 80 minus 15 times 0.6227. So that gives me 70.6595. Okay, all we got to do is divide these two. So the B-C ratio is going to be these two added up, 63.755 plus 35.7009 divided by 70.6595. Punch that in. What does that give you? That gives me 1.407. So the answer to this is D. If your BC ratio is over 1, that means it is a good thing. So this was a good economics problem. They might throw one of these at you. It's good to polish up and remember how to do this stuff. If you have any questions, please let me know in the comments or head on over to Civil Engineering Academy for more tips and tricks related to the PE exam. Thanks, bye.